Every rock on Earth is composed of minerals, with there being a very wide range of compounds and native elements. Since there are currently 6,031 known minerals, some are more common while others are less common. So, which mineral is the most common to be found by volume in Earth? It turns out to be a mineral that, despite being so common, the vast majority of the world's population has never seen it. I am not referring to quartz, the form of silicon dioxide which comprises 12% of Earth's crust, and I am not referring to the feldspar group of minerals which comprise 51% of Earth's crust. Instead, I am referring to the mineral Bridgmanite, which by volume comprises 38% of our planet. Bridgmanite. This means that 2.2699 sextillion metric tons of Bridgmanite exists in Earth. So why did it take until 2014 for this mineral to be discovered? Lower mantle. The answer is that Bridgmanite is the primary constituent of Earth's lower mantle, which is so deep that its minerals essentially cannot be directly observed by scientists, specifically at between 660 and 2,900 kilometers or 410 to 1,802 miles depth. At these depths, Bridgmanite comprises 75% of the mantle, with the other two primary minerals present being ferropericlase and perovskite in decreasing abundances. Before I describe how this absurdly common mineral formed, I want to elaborate on why it took until 2014 to be discovered. San Carlos. For context, minerals in the very top portion of the upper mantle such as olivine are somewhat commonly brought to the surface via the upward motion of magma, which results in volcanic eruptions, with an example of this occurring 580,000 years ago in Arizona's extinct San Carlos volcanic field. This emplaced what is today sourced as 90% of the world's peridot. Olivine is fairly common and stable at the very top of the mantle, which can be as little as 5 km depth all the way to 410 km depth, with most of this peridot in the San Carlos field originating in the upper mantle's uppermost section. To get minerals which occur deeper in the mantle, you generally need kimberlite pipes, which not only transfer diamonds emplaced at 150 to 200 km depth to the surface from the thick lithosphere of cratons, but can also sometimes even transfer amounts of olivine. Transition olivine's deeper cousin wadsleyite at 410 to 520 km depth, or ringwoodite at 520 to 660 km depth. The reason the same chemical formula forms different minerals at increasing depth relates to the extreme pressure and heat rearranging atoms into the most stable arrangement at those conditions. As for Bridgmanite, it forms due to the decomposition of the mineral ringwoodite into the minerals Bridgmanite and ferropericlase at 660 to 2,900 km depth. With a melting point of 2,780 to 5,330 degrees Celsius depending on pressure the mineral experiences, it does not melt in even the lowermost mantle, where temperatures reach 3,000